Hello, welcome to the homework review, homework 5.1, using shadows to find height, ACE problems 1 and 2, 6 through 13. In class today, we talked about how we've been using similar triangles to find missing measurements and how, well, that's a good math exercise. What's the point of it? What can we use that's practical? So we talked about today how you can use shadows to find the height of something that you don't know. So if we have a height of something like the Washington Monument and we want to find how tall it is, we can use its shadow along with something that we do know the height of it next to it. So say a meter stick or something like that can help us find it. And this has to do with the fact that the rays from the sun are all parallel, so they form the same angles. And then we have a right angle with the ground, so we know that all angles are congruent, so they must be similar shapes. So we can use this similarity to find heights. So the first problem, the Washington Monument is the tallest structure in Washington, D.C. At the same time, the monument casts a shadow that is about 500 feet long. A 40-foot flagpole nearby casts a shadow that is about 36 feet long. Make a sketch, find the approximate heights of the monument. So I just did a really rough sketch with lines that we don't know how tall the monument is. That's our X. We do know that the monument has a 500-foot shadow. We know that there's a 40-foot flagpole near the monument, and that flagpole has a 36-foot shadow. So we can use our rules, our ratios, of corresponding side lengths with similar triangles to make up a ratio. So we'll take our height that we don't know and our shadow that we do know. X over 500 equals 40 over 36. And we can use our cross multiplication to solve this. So you're ending up multiplying 500 times 40 and dividing by 36, and you get 555 and a half feet. So the Washington Monument is 555 feet and a half feet. Darius uses a shadow method to estimate the height of a flagpole. He finds a 5-foot stick cast a 4-foot shadow. At the same time, he finds that the flagpole cast a 20-foot shadow. Make a sketch, use his measurements to estimate the height of the flagpole. So again, there's something tall we don't know the height of, we know its shadow, and we know something next to it. So here, X is the height that we don't know. 20 feet is the shadow. We have a 5-foot stick that casts a 4-foot shadow. We can use similar triangles to make a ratio again. 4 is to 5 as 20 is to X. We end up multiplying 5 times 20 and dividing by 4 and getting 25 feet. We also could have used scale factor on this one. We could see that 4 feet to 20 feet is obviously a scale factor of 5. So then 5 times 5 is 25. So either way, you can get 25 feet. These last ones that I threw in here, 6 through 13, I included them because they're good cross multiplication ones. So you can use equivalent fractions or you can use cross multiplication. So here, 5 halves equals x over 8. 5 times 8 is 40. 40 divided by 2 is 20. 2 fifths equals 7 over x. 7 times 5 is 35. 35 divided by 2 is 17 and a half. You do 28 times 5 divided by 7 gives you 20. 3 times 10 divided by 7.5 gives you 4. 35 times 1 divided by 7 is 5. 5 times 60 divided by 100 is 3. 5 times 4 divided by 10 is 2. 6 times 3 divided by 3.6 is 5. Oh, I forgot the secret word. The secret word will be Jazzapalooza. Since I'm going to the Jazzapalooza jazz thing tonight, Jazzapalooza is our secret word. Thank you for watching.